Hi everyone, my name is Arif Ahmed and I'm the team leader of Team Innovate. We are participating in Smart India Hackathon 2023. The problem statement for this year we have chosen is problem statement ID 1329, and this is the description for our problem statement. So in this bit I'll be explaining on how you can download and run our project locally on your system. So what you're gonna do first is we're gonna navigate to our website insight-inc.org and click on the GitHub button. It's going to redirect you to our repository on GitHub, and here you can see all the steps. So firstly, what we want to make what we want to do is we want to make sure that we have Python and Node.js installed on your system. So we're going to click here, and it's going to start installing. Since I've already have installed, you can go through this process, and after installing, you can make sure by running the command Python version, and it should show you the version, and same for Node.js. So this makes sure this show that we have Node.js and Python. After that, what we're going to do is we're going to copy this link over here, git clone and the repository link, and we're going to do cmd again, command prompt, and change the directory to desktop because we wanna we're gonna have our folder on the desktop, right? And paste the command. Since I already have InsightInc on my desktop, so I'm getting this error. But since you won't get this error, you will have an installation steps. It is gonna take about 30 seconds, maybe 1 minute. And after that, what we wanna do is we wanna go to again change the directory to insight-inc and then do code dot. It's gonna open Visual Studio Code eh, with the folder here and let it load. After this, what we want to do is we can create a virtual environment by entering this command in the terminal over here. You can just paste it. Since I already have a virtual environment, you can just copy this and have paste it over here and then enter it. And after that, we're gonna act if you're on Windows, we're gonna activate the virtual environment by entering this command. Same here. After that, we're gonna make sure we're gonna download the dependencies for a Python project. So what we can do is pip install minus hyphen r requirements dot txt. So since I already have all of the requirements downloaded, it shows requirement already satisfied. But you would see a down installation process over here. It's gonna take about 2 to 5 minutes to download all the required libraries. After that, we're gonna download the dependency for the website. For this, what we're gonna do is we're gonna go to desktop, Insight Inc, and go in front end and open command prompt over here. So here you wanna do npm install, and this will download all of the required dependencies for the website. It's gonna take again 2 to 3 minutes. I'm gonna stop it right here because I already have it installed. So after installing all of the project, what we're gonna do is we can run by clicking here, and it's gonna run our Python app. That is the server, the Flask server, and like here we're gonna do npm start. This is gonna run the project. It's gonna take some time. Yep, it's loading. You wanna wait for some time. Yeah. Okay. So you're gonna see the same website, localhost colon 3000, and you can choose NDTV, which we currently support right now, and select any date. You can search. It sends a request and it's working. Now it's gonna start scraping any moment now. So in this bit, I'll be explaining how our technology works. That is the backend and the front end, and I'll be briefly. That means I'll be briefly going over each of the code bases, and I'll be explaining what do we do, and how do we do it. So starting with the backend, we have assets folder. Here we have sample screenshots that our OCR engine, that is optical character recognition engine, uses to extract non-English text and convert it to English. This is not fully implemented because we left it out for the finale. The plan was for this is that we read the whole newspaper that is written in regional languages, and we read it and we extract all the text from it, and then we do sentiment analysis and department categorization. But again, we left it out for finale, so that's why it is only just a screenshot of a specific column in a news of a newspaper. So, and then we have the models folder. Here we have two models, simple machine learning models that are there for our sentiment analysis and department categorization. Here here is for the department. We also have our data sets that our models use to predict the sentiment and the department. So this is the department data set. It contains all the keywords related to the department here, and same for the sentiment. So, okay, so moving on to the app.py, which is one of the code bases that I have personally worked on. Here we have bunch of import statements, which importing functions from different files here. Here, what they do is they it basically connects all the other code bases app.py. It also serves as a Flask server that accepts post requests from the website, and then post requests from the website um, and post requests from the website with the help of CORS, which is the cross origin resource sharing constructor that we have defined over here. And then we also so depending on the news source that we get from the website and the date, the respective f blocks get triggered, and this is for the scraping part and this is for the OCR part. And after the blocks get triggered, the JSON data is returned to the website. Then we have department categorizer.py. Here, what the code this code basically what it does is it uses the data set that we have. It loads the first data set. It loads the data set, and then in the categorize department function, what happens is we clean the text that we get from the app.py. So that's the scraped text or the this English text from the image. So what happens in the pre-processed text is we convert all the characters to lowercase, and then here and in the lowercase, and we also remove all the punctuations from the text. Also, after that, then we tokenize the text. That is, we convert it into the simpler form. With the help of lemmatizer, what we do is we convert the word into the root form, such as like walking becomes walk, running becomes run, etc. And then we also have a regular expression, which again just splits the word, all the common words into it just splits and stores them in a list, and then we return it to the main function. And then we have the transform method. What it does is it converts the data that we have to mathematical values, and then it predicts on that, and then we return the predicted department to the main function, that is app.py. So here in next in the Google Translator.py, we have, as the name suggests, it is serves as it just translates. It uses the Google Translator library to translate all the non-English text to English by iterating over the text here, and then we define it to English, and then we store the data to in a JSON format. We store the data in a JSON file with this key value. And then moving on to graphgenerator.py, we are using matplotlib library to generate graphs, bar chart and pie chart on the JSON data that's being created from uh, Google Translator, and then textcrawler.py. So how we do is we keep here in the for loop, we iterate over the tone key, which is here the tone key, and what we do is we iterate and we keep a track of it. So yeah, in this function, plot sentiment graph, so we keep this graph basically is for showing the sentiment of all the overall data. So we keep track of that, and then we save the photo, sentiment distribution.png, in the png format. After that, we have department graph. What it does is key the same pretty same logic. The only difference is that we have the government body. We are keeping track of government body. So we only keep track of the sentiment analysis related to the government body. So and then we do the same bar chart, pie chart, and then we save it. So then going on to image crawler, pr- pretty straightforward, very small. It just initializes the OCR engine that we have. That's the PyTesseract engine developed by Google. What it does it key we initialize the PyTesseract engine by specifying it the file path here in our file. For this, you actually need to download the Tesseract engine from the Google. So after downloading, you just need to specify it to the file path, and then we use the with image open, and then we pass our image that's here in the assets, and then we call the image to string function to convert, to take all the to read the text on the image, and then we return the image text and the image file path to the app.py, to the main function. And then in the language codes.json, we have key value pairs of the languages that's required by our problem statement, and the languages that our OCR engine will be supporting. We can add more if you want, but these are the languages that our problem statement requires. We don't support all the languages, we just support all the South Indian languages for now, because it's not fully we left this part off for the finale, so that's why it's halfway completed. So that's what it does. And then in sentiment analyzer.py, this is the code that handles the sentiment analysis. What it does is we are using the transformer library, transformer architecture. We are using the BERT model that's trained on top of the transformer architecture. So what it does is that within the Torch framework, we can also use TensorFlow framework, but we're using Torch. So we are calling the BERT model, and then we have our model in this folder. So here what happens is we are tokenizing the text that is converting them into the simple form, like very much similar to how we are doing it in department categorizer.py. And then here, depending on the device that's running, so if we have like a normal CPU, normal computer, that's we run it on CPU. If we have a CUDA enabled GPU, we run it on that, which is even faster. So then we convert all the data into the mathematical value using the dot logits, and then the value that we get after converting, we find the maximum value in that model. So that we use this method argmax, argument max, and then we just define the label, and then we return the predicted sentiment to the main function here. So in finally in textcrawler.py, this is an asynchronously written code. What it does is we are using libraries such as async io and aio http to asynchronously scrape our data from the internet, because the scraping that we're doing is an internet bound task, that is an input output bound task. So what that means is we are going to the website, like if you go to app.py, what we're doing is we are going to archives.ndtv.com, and we are looking for the div tag element, and with the id main content, and then we are scraping the data which is stored in this html element. So to make this efficient and fast, we are using keywords such as async and await, that is part of the asynchronous framework to efficiently scrape, like I said. The alternative for this is we can do multi-threading, but since in Python we have the global interpreter lock, that is the GIL, that kind of does not allow to fully harness the power of multi-threading. So it does. So asynchronous is the best option here, which we for our own task. Then we are using list comprehension. Then we have also have the regular expression. What it does is key, in the NDTV news outlet, we have bunch of news, right? We have sport news, we have world news, but this regular expression makes sure that the news that we are extracting, the news that we are scraping, is related to India only. And then yeah, and then we open the JSON file, we store it in english.json file. And then yeah, and in this second function, in the second function we are extracting the article content, in the article content in from the website, right? So for this we do div id and in storyboard. I'll give a demo on what way how we are doing it. So here we are just taking the article content, and then we also have regular expression again here. What this makes sure is that it removes all the um, non-valid invalid ASCII character, that is like emojis or uh, emojis, etc., and then it replaces with a space in the text that we are extracting, that is the content. And then we predict the sentiment and the department, and then we print to the console. So I'll show how the final JSON file looks like after scraping. So this is how it looks like. It's a list. It's a list. Within that, it's contained a nested dictionary where we have two string key value pairs of ID, source, publication, link, title, text, tone, and the government body. So we have 1,000. Currently, we have set it to 500, because 500 takes around 30 seconds to load on the website. But you can set it to as high as you want, but it's gonna take much time. So that's so this is how we have bunch of different ministries, different data. Hold on. Yeah. So this is the content that we are extracting, and this is the tone of the content, and the department of the content that's related to here. So just to give a demo on how we are taking for archive is archive.ndtv.com. We're going to the website first, and then depending on the date that the user selects. So for example, I'll just select text for January, and in the month of January, you can see we have an article. It's an archive, right? So but we have different we have article related to news, we have world news. So the regular expression makes sure that we do not have this included uh, in our JSON file. So yeah, so how do we scrape is click any of the link, and what we can find is we can find these links are basically it's taking time to load. Where is the element? Yeah, so we can, this is we can do is it's a bit slow right now. Yeah, so yeah, so now we get it. So if we go just on top here, is this part over here, we can find that the bunch of the links that it's stored in this. These are all the links that are stored here. And then if we just go on top, yeah, so these are the links here. You can see it gets selected over here. It's a bit slow right now, but yeah, what we can find is in the div id main content here, the all the links are stored in the main content. So what we do is we just call the method find all, and then we find all the links related find all, and then we define the href property to take all the links, only the links stored in the div id main content element. So and for taking the content of an article, what we can do is the same process. We go to any of the article, we select the text over here, inspect. This is the developer Chrome developer console that we can activate using Control Shift I. What we can do is we can inspect and we can, yeah, so we find that it's in the p tag over here, the paragraph tag. And if we just go on top, we find that it's stored in div class. Where is it? uh, yeah, div id, this is the one. You just go on top and you'll find that this, if you hover over this part of the element, the html code, we find that the whole article gets selected. So we can find the id. We can even specify the id by using class. Div class is equal to this part, but id is something that I found is more efficient and fast, and so we just use this part to select the id. So yeah, and then moving on to the front end, we'll just moving on to the front end, we have, yeah, we have the public and the source folder. Public folder is used by our website to get the manifest data and the logos. This is required by the website. The main source code for our project is in the source folder. What this defines, these are the simple what is metadata required for a React app. The technology that we're using here is React, Bootstrap, and Vanilla Tailwind JSS. So in this, we have home.js and dashboard.js. Here in home.js, what we have is to send the post request here mainly. One second. Yeah, so here in the when so yeah so when the user clicks the submit button on the website, s- first check what the values of the drop down menu is. That is, if it's one of this, we create a variable, we store it in this, and then we send using the Axios library, we send a post request to this our http our flask server that is running on the back end. And then we send it with this header, and then if the response there is 200 and there is no error with the response, we navigate to the dashboard, and then we pass the table data, that is the response data, that is the JSON file data to the dashboard. And then on the dashboard we render the table and the graph and everything. So yeah, so that is all the explanation related to the front end and the back end. Thank you for watching this project demo.